All right, we are live. Eric is not here today. He is, I think, getting his housework done. So I'm Eric today. Hello and welcome to Apropos, a conversation between Clojure programmers that you can join in live on YouTube. We're going to discuss a few Clojure news items and share our opinions on them. Then we'll jump into a REPL and code some exercises or do some demos. If you're joining us live, feel free to comment in the chat and we'll try to address the questions.
All right.
All right, that's the script. That's
you sound
hello.
like a weird, strange robot to me.
I was trying to be Eric.
Not just like some weird reverb I have going on. Yeah.
There's two of you, Mike. There's two of you. That's the problem.
Oh, man.
I see two of you on the screen as well. So are you going to introduce him twice, Mia?
There's the left mic and the right mic.
All right. Oh no, there's too many mics. So
no. Let me get rid of one of myself.
Today on the cast we have Mike.
Just one of me, yeah.
Mike.
Hello.
And Ray.
Hey, hi.
And me, Mia. So I guess one is Mike and one is Fikes. Maybe?
I should only be one right now, right?
There's only one of you now. There's only one of you now. The stream has caught up.
Cool.
You went a bit recursive there, Mike.
I try.
And wait, can we drink water on this thing? I'm always so scared of getting like ice clinking sounds in the microphone.
I think it adds to the flavor. I'm drinking gin actually, but it's a bit early for you, so yeah. It's 9 hours early. I mean, it's 9 o'clock at night. It's gin o'clock. Come on.
Yeah, it's gin o'clock somewhere in Belgium, apparently.
Yes. All right.
So
our first topic is specs this time, right? That we would.
Yeah, we were talking about code quality, weren't we? So we thought we'd have a little chat about what Spec could bring to it, because it's an interesting topic. I think something that I went to the Amsterdam conference, Clojure Days, Dutch Clojure Days at the weekend. Okay. There's quite a few talks about using Spec to test stuff and Spec being used in all kinds of nice places. So yeah, I mean, for me, Spec will be interesting for code quality when you can spec the functions. It's good for data quality when you can spec the data. But, I mean, that's the obvious stuff. But one of the things we're looking at is using Spec to do front-end validation and back-end validation at the same time. That would be quite interesting. I don't know. Go on, Mia.
We've actually just rewritten a bunch of our systems to use specs as back-end validation because, we're using Kafka, so we're publishing messages, and we want to make sure those messages, anytime a message deserializes or serializes incorrectly, we get a crash. So,
whoa.
So the way we can avoid those crashes is by catching them before they get to that stage, and we validate against the spec to do that. So while we still have this pure Clojure data structure before it becomes serialized into a Kafka message, we validate against the spec, and then we can fix it before we get a crash. So it's cool. Big fan Spec.
Yeah. So how do you have like Spec? Do you have coded Spec checks like in your code, or do you like turn on the instrumentation stuff?
Oh no, they're in the code. So we use Kafka Streams, which is a tool by Confluent, and it's a really nice wrapper on all these different transforms and stuff that you can do on your Kafka messages. So Kafka message comes into, we call it a topology. So it comes into this stream processing set of functions. And when it comes in, we validate it against the spec. So we say we're expecting this event, so we're going to validate it against the event spec. And if anything in it doesn't fit the spec, then we don't attempt to deserialize. we just throw the error from there because the deserialization represents a crash, and it's easier for us to recover when it's at the Clojure data level. And then on the way out, we've prepared a new message, so we validate the one that's going out as well. So ideally, we don't get any garbage in or out of our systems, but if we do, we're prepared.
What about the, oh, go on, sorry, Mike. Yeah.
I was just wondering if that helps you catch cases where if you have like a distributed system and you accidentally are running an slightly older version against a slightly newer version in dev, you know, and you're like, oh, thank God, this thing caught something that was mismatched. And
Yep. Yeah, no, that's exactly what it's for. It's great for that. So sometimes if we end up not bumping a topic version, we get topics that have the wrong kind of data on them, and it catches those. And we know that we can just change the topic version and get that back up to speed.
And also when you're developing something and you're about to shoot something out across the wire, it probably helps you. It stops you then before it even gets out across the wire because you're like, you've produced a map that's wrong or something. And
yep. Yeah, that's exactly what it's. Yeah, it's really good, and it allows us to really isolate the problems. Because with distributed systems, one of the big problems you get is how do you isolate where bad things are coming from, and it stops them before they get there. So
Ray, you were going to say something too.
Yeah, I was just going to say that I think from memory, I think Kafka's kind of like just uses like bytes on the wire. Or maybe you can, but do you specify it as Eden or something? So when you actually get it into your messages, you're reading like just Eden, or do you have to do some pre-processing before that?
So we use Avro. We decided to use Avro, and we actually have a little compiler that we've got that will compile our specs into Avro schemas. So we write it. Yeah. It's really nice. We write it as a spec first, we run the compiler, we get an Avro schema out of it. And then that way, anytime we want to update it, it's so much easier to update spec, which is a Clojure data structure, than it is to go in and edit JavaScript. Because these Avro schemas are, they show up as JSON. So the one thing that we've been kind of grousing about for a while, and we're threatening to fork spec over, is there's no docstrings for spec def. And Avro supports docstrings, and we really like to use docstrings for our different our individual keys and for our specs as a whole. So we had to create our own def for spec that allows those docstrings.
So today, if you do like doc on some spec keyword, a registered spec, it will show you, I suppose it shows you that spec, right? Like if you do doc on it. Which is nice, it shows you what the spec definition is, but you'd like something in English there that says, hey, this is a little more commentary about what this spec actually is.
Well, and it's not just our system that's distributed, it's our team. We are a global team. So we want to make sure there's total agreement on what certain keys are and what certain specs are. And we can, if I want to ask a question from someone in the UK, they're not going to get it until the next morning. So we can alleviate a lot of that confusion by having docstrings that people can refer to and that have all the information about what the spec is for.
I wonder if that was like an oversight with spec, or if there's like some specific reason not to include docstrings. It's fairly obvious.
Yeah, they're great.
It's a bit weird as well, because one of the complaints about things like JSON is there's no, it's kind of like there's no comments in JSON. So woohoo, yeah, we can have comments in specs, which is great, but then you lose them, Like you said, docstrings are much better, because they're inspectable.
But they're great. And, with JSON, we can just put in a spec or a doc field that our serializer and deserializer knows how to work with. And then with specs, we've had to alter def to include a docstring as well.
Right.
Where do you put that docstring? Does it like just put it in some map somewhere?
Do you mean in our version of def?
Yeah, how does your macro work? Yeah, does it register the?
Some Jensen or something. Or
yeah. I guess there's many ways to skin that cat. I guess you could.
Yeah, and we're actually, so we've been doing it one way, and we're now discussing doing it a different way. And I'm actually not sure what the latest thought on that is, besides the grumblings about maybe we should just fork Spec and do it there.
Whoa!
Well, that's actually, like, if you think about it, like, how do you actually sit there and do that? And then you're like, well, where do you put these strings? And then that's like, well, if it were built into Spec, there'd be a place to register it right in there. You know,
Yeah,
so if you
exactly.
fork it, then you could just put it in your registered place in the fork. Yeah.
Yeah, so it looks like I'm looking at our docstrings right now, and we've got, so we start by defining docstrings themselves, like as a nil atom. And then we've got an annotate function that makes an annotation for the spec. So we fill in the docstrings atom with whatever the docstring that we're writing for spec def is. It's actually pretty simple.
Yeah.
This is nice. I hadn't looked at this.
So
and
it
then
puts them into an atom then. Yeah.
Yep. And then when you call doc on it, it returns the docstring.
Oh,
so,
you modify doc then, or you have a special doc for it.
Yep. So it goes into the docstrings atom and returns the one for that key.
So that raises a question, like if you had a feature that you wanted in spec, I wonder, what do you do? Do you like post a Jira ticket against the spec repo and say, hey, this is something we'd like? I guess
you make your own.
Yeah, you just make your own. Yeah.
But the thing is, it's, as far as I understand, one of the arguments about keeping spec outside of the language is that it's alpha and it can still change. It really is alpha, so it's not even saying that we can rely on it as a format yet.
That's true. That's true of transit as well, right? Lots of things are still. Yeah.
Yeah, we can't have spec as alpha forever, though. I mean, transit is a kind of side hobby, isn't it? Really,
The fact that it's alpha, you get into this point where like a large swath of the community is now using it, right? And you have to call it what it is. It's like if you change it drastically, then a lot of people are going to feel the pain at this point. It is an alpha, so I think that kind of allows them to change it, because it is, it gives them free reign to make changes. But if you do, you get to a certain point where it's like, yeah, a lot of people are using this thing. Like even core async has got like a non 1.0 version, right? And everyone's got core async somewhere in their code. It's at a certain point, it is what it is. It doesn't really matter what the name is.
I remember having, this is a bit off topic, but I remember having a conversation with one of the guys who was speaking. Actually, I used to work with him at Exascale. He was talking about Clojure, and he was saying, "Oh yeah, libraries. Yeah, what we do is we always look for the version that's higher or equal to 0.3x.
Yeah.
Just somehow some magic number that after someone's bumped it to 0.3, well, yeah, it probably means something,
Yeah, I noticed that too when I started working with Clojure.
It seemed to work out, but God knows why,
There's like all these libraries out there that are not point something or 0 point. Since I'm an American, I'll say it that way.
Oh, sorry.
Yeah, but it's like there's this preponderance of libraries that just won't, make a 1.0 release and just say it's done. Just do it. Release the thing, because people are going to use it anyway.
I think Node.js went that way. And then, of course, you listen to Mr. Hickey talk about versioning, and it all means nothing anyway.
Yeah. I mean,
yeah. Except for saying alpha. I think he was saying, if you say alpha, it's okay.
Sure,
that's a contract with your community that things can change, and it's unstable. But after that, you might as well just forget it, because all bets are off.
And I wonder, like, when, let's say, spec is released and it has the alpha trimmed off the end, you theoretically would still have the old alpha sitting around for at least something, so you don't break everyone. Yeah. Otherwise, it's this painful transition. Like, oh man, these old code now can't work because the alpha namespace is not there anymore, and it's like this.
Oh, but this is Clojure, so nothing will ever break.
Yeah.
Permanent backwards.
Yeah, it's tricky though, isn't it? Because you would hope that there was some kind of way to put an if then else around, like a C-style macro.
Yeah.
Well, of course you could do that. I get it. You could do what Mia and her crew do, and just redefine NS. And then
fork the compiler. Yeah. Use your own homegrown.
It is alpha, so I mean, hopefully
Yeah.
there are features that if enough people find them useful or request, we can start to see roll out.
Yeah. Well, I would like to, it's quite funny. I would quite like to see some breaking changes in the next few months, just to justify the label, you know.
Yeah.
Maybe that's not reaching much applause. Okay.
Don't ask for breaking changes. Someone will hear you and it'll happen.
So one thought I had on just general quality in Spec. So what Mia said sounds like it's focusing on the edges of the system, right? Like data coming in and out, like a gate that you won't let things get past. And then there's the other thing where like you're deep and within some system, you know, like take like the Clojure script compiler. If you go in there, you'll look at, there's like this huge AST of data that you're dealing with. And a lot of times you want to make a change in that code, and you get into this position where you have no clue what the map is that's going to go into a function, right? And sometimes the best way to find out is to run the compiler, you know, and have it call the function that you're interested in changing. And then you say, oh, okay, now I see what the data is. And then you use that to reason about what kind of change you might be able to make. But the danger there is that it's like example-based programming, right? You have it giving you a map that's an example of what it was for that particular call. Whereas if you had specs in there, like concretely, if the AST within the Clojure script compiler had specs, then you could make a change in a function, and you would perhaps know that, oh, you have to handle these cases, right? Because there's not only could it be this shape of data, you could actually have this other thing that you weren't even thinking about altogether. So there's the human documentation aspect that could lend to better quality, where you have a better sense of what the potential shape of the data is that you're working with.
Yeah, well, I think that was one of the use cases originally for schema, wasn't it? Was that, they were getting, looking at the kind of documentation that's available in Clojure doc, like docstring or metadata. There's no real nice way to document the incoming object or the map that you're getting in that might have all kinds of nested data structures. Whereas if you have a spec, you can basically just essentially help with a decent editor, at least you can just kind of follow the keywords up and down,
Yeah, I remember Arya Higigi's talk about that, and he was like, look at this function, and he's like, can you tell me what it does? And the function was maybe like 7 lines long, but it was a typical thing where you have to look at it for a while to figure out the ins and outs of that function and what it does do. And then he said, oh, what if you just had a spec that told you, here's the data that's going to come in. And his argument, I think, or at least one of the arguments, was it would help in developer productivity, because you could understand a function in a different way rather than reading its implementation.
Yeah,
you could actually look at the spec and say, like, oh, the data is this shape. Like you had to deduce the shape of the data by reading the function, basically, which was a painful thing to do.
Yeah, well, some functions you can never really deduce it, can you?
Right. Yeah. It's like they're so open-ended, and yeah.
I mean, I guess you can, like, if you're dereferencing some keys in a let, or dereferencing some keys in the function arguments, then you can kind of say, okay, well, I'm assuming that at least it has those keys. But again, you kind of don't get any guarantees around that.
Yeah, you're just kind of reverse engineering it based on what you're seeing in the code. Yeah,
you're hitting and hoping as well. Then you might have some defensive stuff in your application that says, or this, or this, or this, or this, because there's no guarantee of the data actually incoming.
So I guess there's. Go ahead, yeah.
Okay, well, so in this case, is the spec actually a part of this function, or is it used to capture the decisions made around what the function is returning? Is it separate? Is the spec there to define what the function is returning and then uses validation at the end, or?
I was thinking more along the lines of speccing the inputs to a function, just that simple. Okay. Like you're about to change a function, you don't even know the shape of the data that's coming in, right? Because you're looking in this code base and you've found a function where you think the bug is, and you're like, oh, it looks like I need to do something to this one function. And then you're like, well, what is the shape of the data that really comes in? And sometimes you don't know, right? You can run the program. That's what I would typically do. I'm like, okay, let me put a breakpoint there or a print line, and see what the data is. But then that's not that's not covering all the potential different shapes that the data could be in.
Yeah, and also there are some keys which you kind of like, again, you know that those keys will come. You're assuming those are mandatory keys, like we know for Spec, these are required keys, and other ones are optional. But you could never really tell that before. You know, it was difficult to say that. You know, you'd always kind of have to work it out in the code using ORs. Yeah.
I think that could help quality, just even, you know, just not even mechanically from the compiler help or Spec helping you mechanically. It's just like a human aspect. Like you have something that can communicate the shape of the data, and it helps you logically in your own brain better think about how to change a function and keep it working. And
yeah.
You know.
Yeah, and it's also easy for the computer to read. Usually it's rare that something that's human readable, like it's rare that something that helps things be more human readable also helps them be more efficient.
The only thing I think about it, and maybe this is like, you know, the kind of like the ultimate criticism of Spec, unlike a type system, is that with types, you're kind of like, everything is expressed at the same time. And with Specs, it's out of band. And that can kind of clutter the code a little bit. It can suddenly then you've got more to read, and it can feel a little bit like, oh, okay, I'm not just looking. I mean, it's got value. I'm not knocking that, but it makes, you know, to counter your point, Mike, which is that it kind of makes it more legible. Sometimes, if you use it too much, it will make it unreadable, because it's like the function gets lost in this blizzard of specs and F specs and all this kind of stuff.
What I would like sometimes is when you're writing a function in Clojure, I would almost like to be able to put the specs right on the arguments, kind of like schema let you do, right? The fact that you can do it separately is cool. You know, you can separate and do it, you know, but sometimes I would like to put it right there next to the argument, you know?
Yeah. Kind of like a type hint, but more.
Yeah, like a,
but more.
Can't you? I sort of feel like you can.
That would be cool.
I swear I've seen something like this before.
Well, schema used to work that way, I think.
Maybe just like your code, Mia.
You know what? It's probably something that we have implemented in one of our.
Oh, it's your own fork.
Your fork of Clojure.
It's not a fork. It's not a fork. We call them extras. So anytime we have to add something, so it's spec.extras is where a lot of this stuff lives. But I swear that we have a type hinting thing that uses spec like that, and I'm trying to remember it.
Maybe you have your own version of Defen. But
we do not have our own version of Defen yet.
But I think you're right. It kind of like very simple, nice, compact code that has that good legibility because it's the right amount, then becomes bigger with Spec, right? There's this blizzard of stuff, as you said.
So Zach Oakes says Orchestra lets you do that. So I assume
nice.
I assume the type that we're talking about. What is Orchestra? I haven't seen this.
I don't know. Something that the Cowboys brought in. Zach is a cowboy, you know. Yeah. The Clojure cowboy, but in a kind of cool Western sense rather than the the bad coder sense.
I mean, I'm all for the idea of separating things.
Ray, what's your gin?
Yeah.
I have to try.
Oh, interesting. I'm looking at this Orchestra complete instrumentation for Clojure.spec.
Yeah, even the return values and stuff. Yeah.
But do they give you docstrings? This is cool.
All right, so Orchestra.
Oh, Zach says he's literally wearing cowboy hat right now.
Nailed it. Oh, this is good.
So also,
we've all learned something there, and yeah, cool. The other thing I was Angus Fletcher was saying that he uses it to do all this other integration with Swagger, etc. And I was just going to give a shout out to the medicine boys who've got this thing called Spec Tools that was kind of it was mentioned quite heavily at the weekend at the conference. One of the guys was using it to sort of drive Swagger, which in turn drives the Amazon Gateway API. So you can actually deploy, you create a spec, then have that generate the Swagger, which then Amazon generate an API gateway for you. So it's kind of like from this one little thing, you've got this, again, more leverage coming from this. So you can have like one spec for your API, and then bam, have it just like auto-created in the Amazon API gateway. So that sorry, go on, Mike. Yeah.
They also did something interesting in there, which was to express specs as pure data, as opposed to macros, which I'm like, that's kind of an interesting idea. The data is always good, right? So you can just, if you do that, then handing around a spec is nothing more than just handing around some Eden, that says, here's my spec.
Code is data. Data is code. Simple made easy.
I mean,
it's like Bibles or something. Book of Rich, chapter 3, verse 27.
No, but it is really cool. And like that sounds awesome. Like that is sort of what Clojure is supposed to be doing.
Yeah, if you take that approach, if you define your specs as data, then it makes it perhaps easier to do these Swagger kind of things where you want to derive something from it directly.
Yeah.
Maybe Spec has enough introspection where you can get at the underlying specs, sufficiently well enough to get at the underlying data anyway. So I just thought that was cool. One aspect of that library.
It is really cool. Yeah, I really enjoyed your tweets and all of the tweets around you from the Clojure Days thing, Ray. It looked like a lot of fun. It
was a great conference. Yeah, it was super relaxed. I mean, the Dutch people know how to enjoy themselves. That's for sure. Yeah. And there was quite a few people having a really good time there.
Okay.
I was in Amsterdam. It was my birthday, and also the startup I was working for had just imploded, and people kept giving me beer and ice cream. So it wasn't. That's what I remember about the Dutch. Just
wasn't the worst day of your life.
No, it was a weird day.
Yeah.
Is that where Stroopwafels come from?
Yes, that's right.
Okay.
Yeah.
Those are evil things, but they're good.
Anyway, are we up? Are we? Time is up. We're not getting the big shout outs in the chat yet.
They're not yelling for the REPL yet. Wait, but I get to do it. I'm Ray. I get to do the REPL intro.
You're Eric. Okay.
No, I'm sorry. I'm Eric. Oh, jeez. I know that you look different. You look
definitely different.
You're very different. You have different accents. You just have the same hair and eyebrow portion, which is how I sort people in my head. So
great sifting algorithm there.
It's really bad. The worst is just like if someone acts like they recognize me, then I assume that I know them.
Right.
Because that's what face blindness is like. But I'm Eric today.
Right.
You're Ray. And I'm going to do the introduction to the REPL.
Yeah.
So we are about to switch over to the REPL. If you're listening on the audio version, we'll end it here. You can watch the REPL coding live on YouTube. All right.
Excellent. You had me fooled. You sounded like Eric. Yeah.
Yeah.
So.
Right.
We have the REPL up.
Yeah, it's working for me.
Yeah. Unfortunately, I don't know where the hell this problem is, but I kind of know what the problem is. So.
Yeah, we wanted to write a spec. We wanted to mess around with specs today. We wanted to basically write a spec for a contact list, if I remember correctly. So it's not a problem per se, but it's at least a chance to mess around with spec in the REPL, right?
Oh, there's not going to be a lot of struggling here. Oh, well, actually, the email looks fun.
Yeah, this one probably won't be a hard one. This will be more fun in terms of exploring what you can do with specs.
Oh, no, not a regex.
Yeah, but not a hard one.
They look like cursing.
Oh, they do, yeah.
They do, yeah. Right, we better get into this thing. So the idea for the people watching anyway is that we're going to do like Mike says, a contact list thing, which is very simple. So
so who is controlling the REPL view so we can switch to that? Is that
must be you, I guess, Mike?
I think it's Ray.
It might be me. Let me.
Because when I look at the REPL, when I click on the REPL view in the Hangout, it says Mond on it. So
yeah, but that's just because I'm logged in there.
So I'm clicking on it. It might be me because I started the broadcast. So let's see if that.
Okay, it's up there now anyway.
Okay. Yep, that was me. All right. Hey, we have our REPL stuff from last time, looks like.
Yeah.
I didn't realize it remembered all our sins.
Oh, yeah.
So, Mia, you think this will be an easy one? I think there's like complicated things if you try to do generators and stuff too. I'm still new to some of that stuff, so.
I'm just trying to move my terminal onto this desktop. So.
Oh, I got you.
Yeah.
We're talking about moving to Linux, and that'll be good if it happens.
Linux should always be part of your life, I guess.
Yeah.
You should also use Juxt as often as you can.
So we make a little atom then for the contacts.
Oh, okay. Are you doing like an atom?
Whoa.
Atom?
Yeah.
You're doing some sort of postfix notation there.
It's the gin thing again. Yeah. Sorry about that. Yeah.
The Drunk REPL podcast. Yeah.
Maybe I should let you take over.
No.
I'll be best mate. Come on, Mike. I will.
Is this what the conference was like? This sounds like so much fun.
It's totally like that. But a lot of people spoke like that all the time. I don't know what accent that is actually. It's a Dutch accent, sort of. You screwed like this. That's Swedish. I don't know. Something.
Yeah. Okay, so you made an atom to put the data into. Is that?
Yeah. So then, if we just like do something, and then we can like spec it. So we want a little function, I guess, that says, all this stuff. Yeah. Add contact, something like that. And,
okay, so I think you're doing, I see where you're going. You want to make sure that the atom has like a validator on it to make sure that.
Yeah, basically, yeah.
Okay,
yeah.
I got you.
So we have because otherwise, yeah. So we had a contact, and I guess we just get a contact in.
Yep.
Oh, should we paste has someone pasted the problem into the YouTube chat?
Oh yeah, let's see. I'm going there now.
Angus, that's a bad joke.
Oh my God, recursing.
I don't think we had a well-defined problem.
Swap.
But let's see.
And we're just gonna. I wanted to make that an array, so I'll go back and change that. So we swap contact and we just conj onto it, yeah?
I paste the problem and it's too big.
There's no problem too big for Spec.
I'll break it into parts.
Oh man.
So, so the problem is basically to write a spec for a contact list, and a contact list has a name, a mobile, and an email. The name is supposed to have a string, but no numbers in it. Okay, yeah, most people don't have numbers in their names. The mobile is a string that has numbers and spaces or hyphens, and the email has a lot of verbiage that sounds like an email description. Name is required, and mobile and email are optional parts of the spec. And then contact list is an atom holding an array of contacts. Okay. And the problem is to write a spec for the add contact function. I got you. Okay. Yeah.
Is that your real number, right?
Totally. Yeah. Well, I've got a bug already.
So
let's swap work again.
Let's see. I can't read it because it's underneath the edge of the thing there. Let's see.
Oh man.
So now I can see it now. Let's see. Oh, take out the parentheses. It would be swap contacts, conj contact. Without the parentheses, like the one that's right in front of the conj.
Oh yeah.
Get rid of that paren.
Yeah.
Blow that one away. And then do whatever you need to do at the end to make it happy. And okay. All right.
Oh, lovely.
Okay.
Right. So we'll do it again. Oh, it's too me. We probably should not allow duplicates. You're seeing double. It's not me. That's
okay,
where I leave you now. I bow out gracefully to Mike's specking loveliness. I shouldn't have had the bottle of wine and the 4 beers beforehand as well, really, you know.
Good Lord, man.
I'm joking. It's okay. It's okay.
Are you all right, Ray?
I'm not at a conference. It's okay. Right, Mike.
Yeah, I always need like a hangover recovery week after a conference.
I think the first thing you should do is require the spec namespace so that we can access spec.
Ooh.
Do you want me to do that?
Yeah.
Let's see.
Yeah.
That's easy. I'll do that. Alpha, as we discussed earlier.
Oh, yeah.
It seems like everyone universally refers to it as S. Okay. And we don't have Mia's special fork at play.
So one thing we use a lot of is Clojure.future. Although, oh no, but we're in 1.9 now, so we don't have to worry about that. We've got all the helpful int, etc. stuff.
Okay. So would you start by writing specs for the individual keys, the individual values?
Yeah.
Okay.
Let's just take up our friend.
We can start off with the name spec. Hopefully we have the generators library so that we can exercise the specs. We may have to restart the REPL to get that. That doesn't look cool. What is that?
That doesn't look right.
No. I think we have to put the parentheses in again.
Oh, you're trying to make it distinct. Okay.
Got a little tip from Val in the REPL in the thingamajig.
Oh, okay.
It's not supported in this type.
Well, maybe because you screwed up what's in the atom, you may have to reset it back to an empty.
Well, no, it says it's not supported on this type comp. So it looks like the order of the functions might be wrong. Maybe not, though. There we go. Oh.
But that didn't do.
Oh, do you need to conj it now? Because you did comp vec distinct, but you didn't actually conj it into the atom, I don't think.
Yeah, something doesn't sound right about that.
Yeah.
Yeah, we'll wait for Softland to come back with us. We're not going to put to it. Doesn't matter about the thingamajig, the duplications. Screw that. Yeah,
I agree. Yeah,
we'll sort that out in post. Yeah. Yeah.
So do you want to try to write the spec for name? Name is supposed to be a string, but no numbers.
Right.
So.
Oh.
Like, if you
it's
if you have a
unusual
number
to
in
have
your
like
name,
I think in America you occasionally have like you know over sort of blown the third or something.
right?
But then you'd see it as like
Roman numerals, isn't it?
Yeah.
Like normally like III something. Yeah.
Okay,
But for our purposes, this is a good spec. Let's see. So how would you write a spec like that?
Wouldn't it just be S plus then on the regex or something?
So you want to actually exclude anything that is a digit.
Yeah, but my first inclination would be
But
to
S plus
and,
is yeah.
Let me. I'll make a stab at what I think I would do. S def.
I have to figure out what we've actually made up and what is an actual function in the library.
I would start off with that S and string, and then right here I would put something that would prevent numbers.
Yep.
Let's see. And this will be a function that takes the previous value, whatever, past the first thing here. So okay. And
is it not just come as percent then, or is
say that again?
Is it not just percent, hash percent?
If I wanted to, are you talking about just doing an anonymous function, or?
Yeah.
Yeah, you can. Yeah,
you could do that.
Yeah.
That's the normal way to do it.
Yeah. Either way, you know, just.
Yeah. So
maybe his FN is more flexible, obviously.
Let's see. So let me save this. I want to find a function that will see if you have digits in your name. That. I'll go for some. And then make a a set that has the digits in it.
Oh, that's a nice way to do it.
And the function now contains digits.
Just range 10 now. I mean, I'm kind of against writing strings like that, but okay.
Oh, yeah, it's pretty cheesy, right, to do it that way? Okay. What did I do wrong? Oh, it's not sum with a question mark. I got to blow away that question mark, right?
Yeah.
It's not the sum with a question mark means whether or not something is nil. Okay.
Which shouldn't it be true or false though? It's kind of wacky to me that it's nil.
Yeah,
but okay.
Let me fix that. To make you and me happy, I'll put Boolean there. That does look weird, right? Okay. Bruce. All right.
It's getting harshed.
Yeah. There's something weird about when I hit return, it does it right there. Okay, so now with that, I can go back to the spec definition. Way back there. And then let's say thing that inverts something, not comp. My mind is thinking. There's the function, there's the combinator that you can use to take a existing function and negate it.
Right.
It starts with a C. What is it? Converse? No. Well,
Where is Eric when we need him?
Bug me. I can't remember the name of that function.
I thought it was Converse.
Complement. Thank you, Angus. Okay.
Complement, yeah.
I had just the first two letters. Yeah.
I'm sorry, I'm down a rabbit hole here looking at whether character / is digit is acceptable Java interop here.
Well, I guess the only thing about it is that we're okay here, but what about if we want to use it across Clojure and ClojureScript?
Yeah.
I mean, it definitely works for me, but
This is good.
there's some sort of limits there.
Okay.
Beautiful.
What about, so we've got space, yeah, so it's just digits. So we're allowed spaces and things like that. It's all good. Yeah.
So the
But then wouldn't we have things like control characters and stuff which are weird, because we just want A to Z basically, don't we?
Well, I mean, some people have hyphens. Like, I think that this is, or like, you know, Kesha's name needs to be respected. So
that's fair. I just went for literally what the spec said in English. Yeah.
Yeah, fine, screw it.
Maybe Kesha wrote it.
Yeah.
One thing I wonder at this point, though, is what if you were to try to exercise that spec definition? Would it do anything reasonable? Yeah, that's what I thought would happen. That's annoying when that happens. So we don't have this library included as a dependency right now, so we can't use the generators library to. Is there another? Can we do?
I think that there is. Check.
Yeah, I find that it's kind of annoying that you forget to have that library and then you're stuck without it.
Yeah, no, we absolutely have to require it to use any of this stuff.
But what I was curious about is, like, I think if you try to do this, what it will do is it will then start generating strings, and then it'll randomly see if they pass that next part of the spec, like contains no digits. And so long as it can do that, then it can give you valid names.
But we can drop out and restart it, because restart the REPL.
Yeah,
that's okay, isn't it? Yeah.
Yeah, let me try that.
Because it does remember the REPL history is there. So
yeah, we can scroll back and redo it.
Yeah.
Let me do that. Let's see. How are we starting this? So that's hidden. Doing the dependency in here. This generator thing is, it's like you have to make efficient generators sometimes, right? They have to be.
Yeah, because you kind of know what they're going to be rather than random things.
I'm looking up the dependency for this thing here. Clojure test check. Okay, I got it here.
So you live in this the depth seed and might.
I do. Like, I think it's very flexible if you want to depend on things that are not jars. Really powerful for that. Okay, I think that might be good.
Isn't it?
I'm missing something, you think?
I don't know.
There's something highlighting weird. Okay. Yeah, something's wrong with that.
Is there a curly missing or something?
Yeah, let me go back and look at it.
Whoa.
That didn't seem right in there, huh? missing a closing curly. Right there.
Are you getting some problem with the REPL? Because
I'm not actually seeing any of this.
Mike, it says it's exited. Just 1 second, yeah. I'll have to go to a different room to fix it.
Oh, you have to join the TMUX. Did I stop it?
Yeah, it looks like I'm just going to try to rejoin and see what happens. Okay. Oh, it says no sessions.
Yeah, I'll start one. Start TMUX.
Oh, no, and it's 1. I have to go.
Well, go ahead and go then if you have to.
All right.
We'll finish this one spec without you.
Okay. I will go and figure out exactly what lives in our spec extras library while I'm out in the world. All right. I am out. Right, bye, all.
Later. Okay, Ray. While you were gone, Mia had to go.
Okay, we're all back again.
While you were gone, Mia had to go. So.
Oh man.
Yeah, time is fine. So
see Mia.
Yeah, she's already gone. We'll probably have time, I guess, to do this one spec, right? And see.
Yeah, just about. Yeah.
So the REPL looks like it's working again for me. So I'm gonna.
Yeah, it looks good. Yeah.
I'm going to try to find some of these things that we had before. What I wanted to do was just at least exercise that guy and see what happens.
Yeah.
So let me. You can't control R in this REPL, can you? You can't like backward search. You can. Okay. Something's not up with the backward search. Well, anyway, I'll just type it again. And so we have the contains digit, and we need the spec definition there. And then the exercise call should perhaps work now. Yeah, okay.
All right.
So what typically happens here is, like if you're writing an S and the, if it's just a string, it can of course generate strings all day long. But that if that second part of the and were difficult for it to by chance line up with, it would have to generate a lot of strings in order to finally come up with an example that works.
Yeah, I mean, we haven't got any numbers in this one, for instance.
Yeah, so it's actually working. But what could happen is if you let's see, let me try one as an example of this problem. I'm going to define a foo, be a string, and so that the length of it has to be 15. Okay, so then this one. Tried 100 times to generate a string that was, and if we then go back and like pick a different number, like 2, length 2.
Yeah.
You can do it, right? Because most of the strings that it generates are pretty short, and there's a more higher chance that it'll generate those. So if you need to do the one of length 15, that's where use that with gen stuff. I don't know if you've ever dealt with that, Ray.
I've seen it. I haven't written a with gen. I know the use case. Yeah, the thing you're talking about, but it would be.
Let's see what you can do. The idea is that you around the spec that you're doing, and then you give it a function that will always a function here, right? And you basically generate things, and this is where I have difficulty because I haven't done it often enough. but you right here, you would write something that would generate strings of length 15 randomly. And I'm not going to try to do that now because I can't remember how to. But I find that you often have to do crap like that to get your specs to run quickly enough. Otherwise, you'll end up with like your whenever you're doing generative testing, either they won't work. You'll get that thing that says it can't satisfy it after 100 tries.
Or you get lots of misses that will never be anywhere near the spec.
Well, it'll get lots of misses, but whenever it does work, like this one here with 2, all of them will be length 2, so you'll get valid things out of it. It's just a question of like if we went back and changed that thing to be instead of 2, maybe some other number. Like let's try 5. Exercise that. That one can't do it easily. 3. We've been having problems going up there, but like you'll get into these boundary cases where it can by chance work within 100 tries, but it'll for larger map values or whatever, it just kind of slows down your testing because it's generating a lot of random things and hopes that it'll satisfy the subsequent parts of the spec. So, and sometimes you just have to write generators because your spec is too hard. Like let's say you wrote a spec for an email address, right? That had like all the stuff in it with the @ and all that. There's no way a random string is going to match an email address, right? So you have to make a generator to do that. It's like the
thing I find a bit frustrating about it to some extent is that just in computer science in general is that we haven't got like a random email address generator, just off the shelf somewhere.
Oh yeah.
Like an oracle for these kind of email addresses that we can just ask. So that's, hopefully when we get a few of these things in the Clojure world, we can just share them,
And for the base specs, they're built in, like URI. Those are a bunch of URIs that are generated.
And Inst as well, I think, isn't it?
I think you're right. Any of those. It'll generate random times.
Yeah.
So that's to me that's a big theme, and it was actually kind of surprising to me when I first learned Spec was that you actually do have to write generators quite frequently. Because it's very easy to write a spec that it can't generate.
Yeah. And also at the moment, there's no real, there's no real kind of official or unofficial way other than just putting specs in some place in a Maven jar or something, or in a Clojure's jar to share them, So there doesn't seem to be a way to say, okay, here are some generators. Unless I'm wrong, it would be interesting to hear from the chat if there are sort of collections of generators out there or other kind of spec artifacts that that can be reused by the community,
Yeah, because it's kind of silly for us to each
Western
reproduce efforts of writing a string generator and I'm sorry, an email generator.
Never going to get everything right, but there are certain things like you've just done there, like email, or there are many data types. Like UK postcodes are quite annoying actually, but there is a spec, so you can have certain numbers and digits, and obviously places like there's a whole postcode database online, and you could in theory just write specs against all of them. I for when I was learning Spec, I did that for like addresses and spec'd out postcodes for different countries. But yeah, you have to write the generators for them because otherwise, it's never gonna randomly produce a Belgian postcode. Yeah, because that's a 4-digit number. Or unlikely.
Now, the one thing before I'd like to at least talk about real quick before we wrap up is this idea that that basically S keys and how the key specs are separate from that. So like I'd like to just do it by an example. Like if you if we were to carry on and we were to say, let's define a contact spec. So far we've done name, right?
Yeah.
What I think is cool. Let's say we have that, and let's say we were defining some sort of spec for something, sdef foo, which would be a map, as keys. Let's say it has to have.
Which will eventually be the contact details. So it will have an email, and it will have, you know. Yeah.
So let's say we wanted.
Requires a name, so we've already got that, so that's good.
Yeah, and the thing I wanted to illustrate is, let's say, all right, age. Let's say you had something like that in there. So you know a foo has an age, and did them in reverse order. Okay. So exercise this real quick. Okay. So foods have ages in them.
-3 is tricky, but you know.
Yeah. That's an interesting age.
Joking.
But yeah, I guess that you could use that nat int thing. But what's really cool is if you then say svalid foo, and then I put into it age 12, and then I put a name in there. I mean, I need to put 2, right?
Oh yeah. I missed out on the name spaces.
And then I put name bar. Okay. That's valid, but then if I put in numbers in there, it won't be valid. That's the thing that I wanted to show. And if you do explain, it'll tell you that that name thing is not.
Yeah, so you kind of pick it up as it goes along.
Well, it's that a core concept in here is that the name spec is the name spec all on its own. It's independent of what maps it might be used in. So if it happens to be in any map, it's going to validate it. And what that means is that the S keys is only saying that it requires these keys to be in the map for it to be a valid foo, for example. But anything else that happens to be in there still has to be valid, right? And that is what it is. But what I think is where that's really cool is like, let's say you're working on a reframe app and you have an app DB and you're shoving keys into your app DB and you're using specs for them, right? But you didn't say that your app DB required this key to be in there. Your app DB could have a spec that does not, enumerate all the keys that have to be in there, but yet you shove like a name in there, and it happens to be incorrect because the default reframe setup, or at least you can set it up this way, is you can have it checking, do spec checking whenever it swaps something into the reframe atom. It'll catch things like this. There's probably lots of other places where it catches things. I just think that's cool.
That is cool. That's where you get like things for free, isn't it? Which is nice.
Yeah, it's kind of like you get more leverage. You defined your name spec, and then it's like, okay, now you've defined that. No matter what map it appears in, it's gonna automatically do it. You can even do something silly like right here. You can, instead of saying foo, just do s/keys. Like I'm making a spec on the fly right there, right? Bruce. What do you like hit to make it enter there? Whatever. Go to the end line. Anyway, so just any spec like that S keys is like a degenerate map spec that's not saying that it requires anything, but it's I'm validating that map that I passed to it.
Right.
And it'll catch it no matter what. Anyway, I thought that was cool.
Yeah, it's cool. Yeah.
All right, I have no other ideas right now at this point.
Yeah, it's okay. I'm trying to check actually with the YouTube whether we're still live or not. I have a feeling that the feed is dead.
Oh, I'm seeing it.
Oh, okay, cool. All right.
Yeah, it's still live. Yeah.
Yeah. All right, cool. Well, I think we'll call it a day, shall we? I think this has been good. Maybe we could like come with a pre-baked one next time and just play around with it.
Yeah.
You know what I mean? 'Cause we're kind of fiddling around with some of the basics here, which is, the people love us to to drink gin and fail at the REPL, but
flailing.
As you come with one bake next week, well, we'll be organised when Eric's back. Yeah. All right, Mike. All right. Well, I'll see you next time, eh?
All right. Ron.
Okay. Bye. Cheers, guys and girls and all nice people. Okay. Bye.